As Björn hinted at, I succeeded him in his position at the Swedish Museum of Natural History in 2014. And I made that graph of the age structure of our network based on 300 people or so. And I have the slightly, funny but also difficult task of moving that age pyramid to the left. You know, recruiting more younger people. It's difficult, but we, as Björn said, the number of monitoring guys, female component is sorely missing in also. We have a hard time finding new recruits, which probably is because we have a different environment than back in the 70s. It's a lot more difficult to find people willing to work for free nowadays. My little talk today will be about contaminant trends in Sweden. And, Björn outlined the big picture for the last 50, 60 years. Many of the slides I will show you are on purpose more or less the same, but I will focus on some more recent trends, sort of what happened in the period that had elapsed since the last Sea Eagle meeting in 2000 in Sweden. So I will pinpoint some future directions, some recent trends, some recent problems that we have to address. And it's important to stress there's two sides of the coin here. One is, of course, the well-being of the eagle population. And that we cannot say from a Swedish perspective that contaminants are perhaps not a big issue today. It was a big issue for the conservation of the entire population. But the other coin is the state of the environment. We can use the eagles as an environmental sentinel. And in that respect, top predators as the peregrine falcon or the white-tailed eagle are still at the very... we need to keep monitoring of those species to be able to monitor effects of contaminants and pollutants in the environment. And as I will show you, based on Björn's previous work, is that we will still see lots of biological effects, even today, based on contaminants that were banned 50, 40 years ago, which is a bit scary, but that's the real picture. I work at the Swedish Museum of Natural History. We have the largest and oldest specimen bank in the world, going back to the 1960s, and we are focusing on our department on specifically long-term time trends regarding contaminants in the environment. This work is funded by the Swedish National Environmental Protection Agency, and we have also done this work over the years in close cooperation with the Swedish Society for Nature Conservation, but we have now officially ended the conservation project and is strictly based on monitoring the population. So, yeah, just to remind you, the situation with the contaminants, it wasn't contaminants that drove the population almost close to extinction. It was severe persecution. We have to sometimes forget that. But it's always good to remember when we talk about this that the low population levels were caused by severe over-harvesting, hunting and stuff before the eagle was protected, at least in Sweden in the 1920s. Okay, in the wake of Silent Spring, we now know that raptors are textbook examples that show up on every cover of ecotoxicology textbooks, such as the peregrine falcons. Interesting books such as DDT Wars by Charles Wurster have been written about this, worth reading. And raptors still maintain an important role in environmental monitoring, not only for historical reasons, but also because of the problems partly persist today. Well, in Björke in 2000, Björn presented this with his almost lifetime achievement of studies on the eagle reproduction, an important paper that was published in Embryo in 2002. And I will sort of build up on that and focus on what had happened since. You all know that this feeding project was partly, in the beginning, one of the hypotheses was to detoxify adult eagles. Didn't really work, but it helped increase survival of the juveniles, and that was the main goal and achievement of the feeding program that we have now terminated since almost 10 years ago in Sweden. And just to show the numbers that we have over 800 territorial pairs in Sweden at the moment. About 60% are breeding along the Baltic coast, some pairs on the west coast, and we have a large expansion going on in the south and middle inland. And this is sort of a 10-time increase in population size over 40 years, if I summarize it briefly. And then one might, of course, ask, why are we still monitoring them? Should we prioritize anything else? With an increase of 10 times over this time, is it still worth pursuing the monitoring? And yes, we say it is for quite a number of reasons. In the slides that I will present, I have used some sort of abbreviations for the different regions I'm talking about. So we have the Bothnian Bay, the Bothnian Sea are divided in two parts, the northern and the southern. We have the Baltic proper, which is also have two parts, the northern and the southern. And then we have the west coast. And then we have three inland sort of parts, where we have Lapland up there. So those are the abbreviations that follow in some of the slides I will show you. And of course, this is a situation that this is why the eagle is good as an environmental indicator. It feeds on everything possible in the food chain. And much of our work, although is based on analysis of contaminants in eggs. That's because eggs, of course, we know so much about. So much work has been done about them. Not so much work, for instance, on contaminants in blood and feathers. So it's easy to make comparison between different regions by studying eggs. And what we usually do each year is we analyze the pesticides, chlorinated compounds such as DDT, DDE, and PCBs, and also nowadays the brominated compounds, that is flame retardants in various configurations. And increased interest more lately in the perfluorinated compounds, PFAS, and those kind of substances that are used, for instance, in textile industries to quite some degree. And we focus on time trends, geographic trends, and most importantly, biological effects, and there are links to reproduction and these parameters, productivity and shell parameters. And the patterns, comparing from Björn's perspective over 50 years, that we have both increasing and decreasing concentration in the different contaminants. We see new geographical patterns. We have seen a reappearance in an old DDE-related syndrome, this desiccation of eggs. It has re-emerged in the past 10 years. And as a follow-up to that, we see extremely high concentrations. Some of the highest concentrations ever found have been found in the last 6 or 7 years. And these are the old compounds that were banned 45 years ago, which is a bit strange. So to summarize, the eagles are good when we look at screening studies, but also the legacy of persistent organic pollutants such as DDE and PCBs. It cannot be forgotten, not even still. So I still urge people not only use eagles as screening for screening studies, but also look into those legacy POPs, as we call them. They cannot be forgotten yet. These slides Björn already showed you, so I keep moving on to some trends in flame retardants. This is one called HBCDD, hexabromocyclodecane. It's a brominated flame retardant, and we see that, concentrations increase in the Baltic proper, also in the Gulf of Bothnia, but we have no statistical significant trends in the inland and Lapland populations. Increasing trends, we have not been able to connect this to biological effects yet. Here's PFAS. The gray line here is white-tailed sea eagle. The blue is herring in different basins of the Baltic Sea. You see that the rate of increase is similar in herring and white-tailed sea eagle. But we have not been able to document any effects yet of PFAS in the Baltic Sea. Some of these substances are now being banned, so we expect a decrease in PFAS and the brominated flame retardants. And it's also important to stress that the concentrations are not high enough yet to cause reproductive disturbances in eagles. But we are not sure what the future holds if this pattern continues despite these substances being banned. So if we look at the correlation between productivity, number produced per territorial pair, it's still the DDE where you find this sort of significant relationship negative. Otherwise, there is no relationship between flame retardants or PFAS. That's even the opposite direction. So what we have found so far is still the old DDE that's causing the problems. And one of the problems that, of course, we have to deal with is high covariation between different substances. So it makes it, from a statistical viewpoint, almost impossible to tease out which is the cause and effect, or if we have a high effect of DDT or DDE, how can we disentangle that from the effect of PCB and brominated flame retardants? That's a really, really tricky question, which is also hampering the progress in this field, I would say, because now we're facing a situation where overall more and more contaminants are in the environment, but at lower concentrations, the same, say back in the 70s. So how to deal out, find the effects of such cocktail or synergistic effects is one of the main topics for future research, to find out how do these combine. Not easy, but what we should focus on. Well, just to show you, DDE is still an issue. These are the concentrations in different geographical regions. And you can see, first, the blue here, inland populations are low. And you have 3 different effect levels. Here at the first line, that's where DDE levels, where shell thickness is beginning to get thinner, according to the slides that Björn showed in his presentation. And then you have another level of DDE around 120 ppm. That's when productivity begins to decline. When you're above 170, then there's the level where you can expect to see this desiccation of eggs because of this shell membrane dysfunction or shell structure changes. And you can see that the inland populations are way below all of these effect levels. Many of the coastal populations, virtually half of all our eggs that we collect still today, these are samples from the last 15 years, are above the threshold where you can deduce some sort of effect on shell thickness. And if you look at particularly this region, the northern Bothnian Sea here, there we are still having close to the levels where you can expect, or even changes in productivity and even desiccated eggs. So this recent picture, from recent samples I should say, still shows that DDE can still be an issue, in fact. These are things that we don't need to discuss further. We have already covered them. And this is a picture of a desiccated egg. They first reappeared in 2008. There was a common syndrome back in the 70s. But we have found in this Bothnian Bay in the northern part at least 6, 7 territories where females actually lay these eggs. And as someone pointed out, the population is doing well, so it's not a problem from a population perspective. But that we still see this means that over the past 10 years something has happened. One thing that has happened is, of course, that the eagles have recolonized this area. They were not there in the 70s and 80s, so we could not detect them, these problems. But it could also indicate that there is some other thing going on, some hidden source of where does this come from is one of the things that have been focused on quite a lot. Here's a map where you see the bigger red symbols. Those are eggs that are collected that are above that 170 ppm threshold where you can expect desiccation of eggs, sort of. And some of these eggs are, in fact, very desiccated also. So it's a fairly concentrated region here where you see the problems. You can see also, so compare it to the Baltic proper where you don't see any of the red dots, meaning that in the southern Baltic Sea, we don't have a problem at the moment, and also in the inland, it's okay, but it's this region here. And what do we have there? That's the problem. This has gained a lot of interest in press. These are Swedish headlines from TV, newspapers, and where I don't translate them, but along the line, the eagle eggs are mysteriously dead, and why don't they have any chicks? So there's a lot of interest in the society. And this is one of the areas where we have a large concentrations of pulp or paper mills, which depose fiber banks outside of the mills. And you know that a lot of contaminants were used in the forest industry back in the days. And this is also the area where we have the highest uplift of the land after the glaciation. So we have an increased rate of underwater erosion and slides that could be release contaminants to the environment. That's one hypothesis, how the eagles in these areas are increasingly getting this back into their systems. So there's a large geographic mapping going on in Sweden at the moment to find out where are all these fiber bank deposits, and is it a severe concern for environmental issues. Another hypothesis is that this is along the area which is called the high coast in Sweden. So there are deep waters with low possible feeding grounds. So we were also having the hypothesis that in this area eagles were feeding more on sort of fish-eating birds rather than just fish, which means that you could get a higher concentration just because of a longer food chain. But we don't know. We have made a specific study about this, which of the two hypotheses is most likely, the paper mills or longer food chains, but we haven't support for none of them yet. So that's one of the things that we're working at the moment, which is a very interesting idea. And just to round out here, what I'm saying is that we still see problems. It's not of population concern, but we need to focus more in the future on how can we use other matrices than eggs, feathers, blood samples, how can we compare them to egg samples? It's not self-evident that it's going to be doable to compare different matrices right away. But there's a lot of interesting things that can be done in the future with new techniques and integration with other monitoring projects. And with that, I thank you for your attention.
So, sorry, but hopefully we have a little bit. So maybe 2 questions.
Спасибо. Вот отмечается рост численности в целом популяции орлана-белохвоста на исследованной вами территории. При этом также отмечается рост высохших яиц или низкий, если так можно сказать, низкий репродуктивный показатель. Как вот это соотношение? Вы бы объяснили.
How you explain the contaminants found by you and quite high reproductive success of white-tailed eagle together?
We cannot really explain it fully because we can see that some pairs lay these bad eggs and then their neighbors are doing perfectly fine. So we cannot really explain. It's not an overall dysfunction of the system. Some pairs, most pairs, 85–90% do perfectly fine. And then there's the rest that somehow we don't know if there is on their breeding grounds or if they winter somewhere on some rubbish dump or whatever it is, or if it's some leakage from somewhere. We don't really know. But that it's true. It's a paradox which doesn't really match.
Good. And the second and the last question?
Yes. The sea level is going down up here. Is that the reason why these containments is coming up and is available for birds and fish and so on?
Yeah, one thing. And the uplift of the land causes erosion and underwater slides. So that's the main reason. Yeah.
Good. Thank you to Peter.